All right, we got our friend Robbie the Rodent. Robbie the Rodent was walking the alleys of Chicago looking for a piece of cheese. He walked 3 miles north, 5 miles east, 5 more miles north, 10 miles east, and 10 miles east during the trip. If you walk back to a starting point in a straight line, what was the total distance traveled? All right. Let's think about this. Robbie the Rodent walked 3 miles north. Always draw yourself a picture. 5 miles east, 5 more miles north, then 10 miles east. Okay. So, how many total miles did he walk north? He walked 3 plus 5, so 8. How many total miles did he walk east? He walked 10 plus 5, so 15. I want to find the straight line distance from where he started to where he ended. Right there, so that is my x. Oh, look, we have a right triangle. Oh, look, that means we can use the Pythagorean theorem. Okay, so now I can say that, hey, x is our c value because it is a cross from our 90-degree angle. Some of you may know this is a triple, 8, 15, 17. If you did not know that it's a triple, I can solve it using the Pythagorean theorem. 8 squared plus 15 squared equals x squared, since x is our c. 64 plus, I think this is 225, equals x squared. 289 x squared, square root both sides, x equals 17 miles. Now, some of us may also add the 8 and the 15, or may want to, but I should have made this question a little bit better. What was the straight line distance traveled? That's what we should have put. Okay. Basically, you need to understand that we're using the Pythagorean theorem here. Let's go to number 12. So numbers 12 and 13, all right, we're talking about altitudes on hypotenuses. We're talking about our small, medium, and large triangles, okay? Remember, I want to think about my small triangle. If I have 2 side lengths, then I'm going to take that triangle out of the picture. If you look at our smaller triangle here, I have a 60 and 36, so I can redraw that. I look at my medium triangle, not so much. And if I look at the large one, I can redraw the large one where it's 60, and then I just call this one x. Now I gotta think to myself, hey, what appears twice? Oh, the 60 appears twice. So I go 60 over 36 equals x over 60. Or I could also say 36 over 60 equals x. Or excuse me, 36 over 60 equals 60 over x. Cross multiply from here, now we're just solving a proportion. 36x equals 3600. Divide both sides by 36. X is 100. Same type of problem. Small, medium, large. Small triangle, yes. I got the 9 and the 12. Medium triangle, also yes. I got 12 and x. I'm going to set it up the other way. 9 over 12 equals 12 over x. Either way is fine. I can go 12 over 9 equals x over 12. I just want to show that you can, I'll show that way as well. 12 over 9 equals x over 12. Our goal is to multiply whatever appears twice by itself. All right, that's our goal here. If you recognize that, that's all we're doing. Then cross multiply itself. 9x equals 144. And I think, I don't want to say it out loud. All right, good. I got it right. 16. Wow, math teacher. Here we go. Let's keep going. We're flying. We're having a good time. I can tell. Lego. What the heck? All right, whatever. So here we go. I got the small triangle. I'll redraw the small triangle. I have x and 25, radical 3. Medium triangle as well. I have 25 radical 3, 75. Oh, what happens twice to 25 radical 3? Don't be afraid of the radicals. X over 25 radical 3 equals 25 radical 3 over 75, or 25 radical 3 over x equals 75 over 25 radical 3. Whichever one makes more sense to you is fine by us. Crisscross applesauce. Here we go. 75x equals, I'm going to do 25 times 25, which is 625, and root 3 times root 3, which is root 9. Oops. An equal sign. Times root 9. All right, well, remember that root 9 is 3, so I'm going to end up doing 625 times 3. So I have 75x. So this is 625 times 3. 75x equals 1875. So the key with this one, okay, was the radicals. That may trip people up. All right, and when you're multiplying radicals together, okay, when I'm doing this 25 root 3 times 25 root 3, multiply the outside with the outside and the inside with the inside. All right, I want to multiply our constants 25 with 25 and whatever's underneath our radical together. Root 3 times root 3 to get that root 9. All right. For whatever reason, I gave myself a lot of space, so let's keep going. I guess I needed it. So I got my small triangle, the 50 and the 25. And I got the large triangle, 50 and x. Whoa. So what appears twice? Oh, 50 appears twice. 50 over 25 equals x over 50. Or 25 over 50 equals 50 over x. Cross multiply. I'm having so much fun, aren't you? 25x equals 2500. Divide both sides by 25. X is 100. Okay, let's keep going. 11. Use the figure on the right to solve. DG equals 4. GE equals 9. Find F to G. Find X. So it looks here like I'm going to use my medium and my small. All right, so I have the medium of 9 and x, and I have the small of 4 and x. Oh, what appears twice, people? It's the x. X over 9 equals 4 over x. Cross multiply. X squared equals 36. X equals 6. So FG is 6. Now, basically, I just have to do the Pythagorean theorem about a couple more times. I'm going to call this y and this one z. Okay, so my next Pythagorean theorem, I'm going to want to look at the medium triangle. I can do the small triangle first as well. I'll just do the medium triangle. So I have a triangle here. Okay, this is 6 now because I found FG was 6. All right, and now this is 9 still, and then that's my y. So y is my c. So I can do 6 squared plus 9 squared equals y squared. 36 plus 81 is 117. So square root both sides. Y is just the square root of 117. And that's FE. Does that divide? Oh, well, that does. I'm sorry. You can simplify that. Square root of 117, I can divide by 9. I apologize for that. So it would be 9 and 13. So y equals 3 radical 13. right? My other triangle, I'm going to use a small triangle. 4, 6, and z. 4 squared plus 6 squared equals z squared. 4 squared is 16. 16 plus 36 is 52. Square root both sides. 52, perfect square multiplies into 52 is 4. 4 root 13. So z is 2 radical 13. Now, did I have to do the Pythagorean theorem 2 more times? No. What would I have done? I could have just done this process again. But I think personally that this stuff down here in black might make more sense to the stuff in blue. All right, might be easier for us to understand. I think I think in the past, people have always been more comfortable using the Pythagorean theorem. So we try to do that. All right, I'm going to pick up on number 14 on the next video.